All right, everyone. I'll be presenting about generality of lexical disambiguation of noun-noun homographs in GPT2-small. So if you're looking for SAEs, sadly, my presentation is not for you. There will be no SAEs. I'm very traditional. I'm very old-fashioned like that. All right, let's begin. So let's consider the sentence, he made a bow. What does that mean, right? What does that sentence mean? Does it mean that he made a weapon, or that he bent forward at his hips? So when I say he made a bow, and when I say he made a bow, you are able to tell which one it is because of the sound, right? The pronunciation is different. But the thing is that LLMs can't read that because, they're not audio models. They can only understand text. They can only read. So here, I just want to clarify a little point here about homonyms, homographs, and homophones. So, oh, is it not? Is there something? Okay. So homographs are words that have the same spelling. Yeah, they have the same spelling, but they have different meanings. So for example, you have bat, which means the animal, right? Bat, which means the animal. And you also have bat as in like the baseball bat. And you also have homophones, which are words that have the same pronunciation, like eyes and ice, right? Ice is in solid water and ice is in the sensing organ. Homophones are words that are either. And for me, since I'm working with text language models, I am concerned with homographs, right? Because they're going to be represented by the same tokens. And if you don't know what tokens are, I'll explain them in a bit. Oh, and by the way, see, it's kind of confusing there because sometimes homographs are treated as a single word with multiple senses. So it's like a polysemantic word, right? So this is just like, if you see it elsewhere that is described like that, there's just like a little note for you. So tokens, right? How do large language models read, right? They don't read using letters. They also don't read using words. They read using tokens, which is when the stream of text is divided up into chunks for it to be able to more easily process. And you can see here, how do large language models read? They read using tokens. Tokens aren't letters, but aren't quite words. And you can see how it's divided up into each one. So you see here, like for example, like the question mark is its own token and the aren't, it's separate, right? So this is how large language models read. So, you know, uh, words which have the same spelling will be represented the same way because they will have the same tokenization. So if you know a little bit of linguistics, you can analogize this to being like lexemes. This is a good analogy for them. Right. So now let's consider bats. In the sentence, she saw a bat. What does that mean? Right? Does it mean that she saw a wooden stick? Or does it mean that she saw a flying mammal? And it's impossible. There's no way to find out because again, right, here you have the advantage of being able to hear me, but in this case, the pronunciation is the same. So you wouldn't be able to tell. The only way you would be able to tell is through context, what's surrounding it, right? In what circumstances am I saying it? What things have I said before? What things are in the environment? Then you'll be able to tell which sense of the word I mean. So this is called lexical disambiguation or word sense disambiguation. And the model simply cannot memorize the meaning of the token. It also has to consider it in the context of all in which it lives and it came before it. And only what came before it. Because, GPT, it only predicts the next token, right? So it can only see the past tokens. So let's try that exercise again, but with context. In the stadium, she saw a bat. Now with that clause right there, that gives you a lot of clues. So now you will be able to say, you will be more able to confidently say, okay, more likely to find baseball bats in an arena, so I will take this interpretation. And on the other hand, in the forest, she saw a bat. More likely that you'll find animals in the forest. So you will be more likely to think of this being the case, of the bat, of the word bat being meant in that sense. Right. So we already know that models can use context to disambiguate, right? Because they can produce text that is sensible to us. You know, they use words in the same way that we do. So clearly they have the capacity for it, which means that they can understand the meaning of that context and use it to make informed guesses, right? I mean, if you understand a little bit more about transformers, right, with what Clark said, they want to minimize the loss. They want to be able to predict the next token with as much accuracy as possible. So that is how they do it. If you want to understand how LLMs work, we have to learn how they see and understand the world. We have to learn how they model, how the models model. So finally, I'm going to talk about my research. So the scope of my research is I'm only going to be considering noun-noun disambiguation, right? So bat can also mean to hit, but I'm not going to consider that because it's a verb. So that will take like a different position in the sentence, and that's like too many variables. I can't with that. Not going to consider it. It's a lot simpler to do it like this. And it's a lot like, the result is more robust in a sense because you're changing fewer variables. And I wanted to find out what parts of GPT-2-small do noun-noun disambiguation, and also find out how distributed or centralized this capability is. Like, is it only like a few parts that do it and like they do it for all of the nouns? Or is it that it's everywhere, right? And like every part of the model, like most parts of the model contribute to it, and it can't be like isolated into a specific thing, right? So you can kind of like analogize this to how the Discord ping. Yeah, you can kind of analogize this to how, you know, neuroscientists, they will take measurements of the brain while doing different tasks, right? And like see the blood flow, right? So this is sort of what I want to do, except, you know, I don't have to get human subjects for it. So my prediction is that it's going to be distributed because like there are a lot of different nouns out there with many different meanings. So, you know, it makes sense to me that it will be different, right? Because it is a matter of semantics, not grammar, and not just syntax. But we'll see if I was right in predicting that, my hypothesis. I also chose GPT-2-small because I felt that it was large enough to perform that task because larger models are able to handle more complexity, and this task requires involves quite a bit of complexity. You know, with smaller models, you know, they only work with say like ABC, and like you predict like the next token, like one of the three, either like ABC, that kind of thing. So I need something a little bigger than that. It can't just be a toy model, but it's also small enough to be wieldy, right? This is my first time doing any sort of serious research, and I didn't want to try, you know, using like a very big model that will take a lot of compute and also take up too much time trying to analyze. So here, I'm going to use edge attribution patching for it. So the thing is, right, how do we find out how the model disambiguates? How do you find out where in the model it disambiguates? There's an assumption that we can make where if I alter some parts of the model that are necessary to perform the task, then the output and the performance will change. But if they're not necessary, then I can do whatever I want with it and nothing will happen to the output, right? If for a specific task, like for example, if I lose my arm, that will impact me running a lot less than losing a leg. So we can conclude that the legs are more important to running than the arms. So I'm just going to go through like a little technical bit here. Typically, we do attribution typically we do them on nodes. So you see like these ones, like the attention heads or the MLP, multi-layer perceptron, and then the output, right? So let's say that I change the attention head, I alter it. All of the changes, all of the changes will be propagated downstream. So if I change the attention head, it will also change the MLP and the output because all of these are downstream from it. But I wanted to do something a little bit more like precise, I guess. And I also read that this has also better uh, performance and faithfulness, where if we rewrite this into this, like they call this a factorized state, we can think of this as, each module like feeding into each other. We only change the edge. We don't change the node. So if I wanted to change attention 1, right, I'm not going to change the whole thing. I'm not going to change like the MLP and the output. I'm just going to change the MLP or the output, right? So in this way, you have more granularity. And then I wanted to create the prompt data set. So the mechanism by which this works is, oh, sorry, I want to go back. Okay. The mechanism by which this works is you have 2 prompts that differ in some value, or like they differ in the task that you want it to do. So then you run the model through it. You run the model on the prompt for each one, and then you measure what changes. So that means that I need to create a data sets which expose that. So here, I wanted the prompt to contain context to nudge the model into an answer. So here in the cave, in the forest, at the zoo, and on the other hand, in the stadium, in the arena, at home plate, and then elicit knowledge of the model by asking it to complete. So here I say, was the bat an animal or an object? It was and then I ask it to fill it in, right? So then like the prediction of it would show us like what the model understands to be the case. So I made 3 data sets for this. I made one for bats, I made one for boards, and I made one for bows. It just so happened that all of the words that I selected started with B. That was not intentional on my part. Right. So then I wanted to identify also the circuits that were responsible for it. So a circuit is a set of the model parts or modules that are the most important for some task, right? So the ones that are the most relevant, the ones where if you take them out, it will totally like lose the ability to, or performance on the task will be severely degraded. So I use a method which sorted the edges of the model based on their importance, right? The average logit difference between the 2 things. So let me just explain a little bit on how I did this. You see here, we have, say, in the cave, I saw a bat. Was the bat an animal or an object? So this is one prompt. And I would pair it with another, which has the object bat context. So instead of in the cave, it says in the stadium. And I would compare those 2. And by comparing them, I will be able to visualize the circuit, right? I will be able to see which edges had the highest difference. So here I'm going to be showing you some visualizations. Blue means positive contribution. It pushes towards the correct answer. You sort the prompts into the correct answer and the incorrect answer. Here, the correct answer that I set was animal. Red is negative. It pushes towards wrong, and the width represents importance. So here is the bat circuit. I have the example prompts here. I have an example of each of the prompts. So you see, it's all very clustered down at the bottom. So GPT2-small has 12 layers. So you see the most important ones start like 8, 9, 10, 11. Those are the ones that are most important, is later. And that does accord with my like intuition that more complex computation happens at the later layers. That's generally a theme that you see with transformers, where more complex things that require more moving parts in order to be able to be calculated, they tend to occur later on in the model because more other things have been able to act on them. So here I also had one for board. So the charity did have a board. Was the board composed of people? Was it people or wood? It was composed of, and the ceiling was under a board. Was the board composed of people or wood? Right? So board as in like board of directors, and also board as in like the wooden board or like a blackboard. And here we also see that it's clustered at the bottom, right? So it does seem to be the case that it's like that. And now I also went to the bow circuit. Clara the Smith made a bow on the bench. Was the bow an action or an object? It was an. Tom the actor made a bow to the audience. Was the bow an action or an object? It was an, and here I was really surprised because it was like, wow, now we have like action on the earlier layers of the model. And see, I'm not sure why this is the case, but I think it has to do with the fact that here I made two separate changes. See, you see, I changed this Clara the Smith and then Tom the actor, and then here I also changed it to be I also changed the latter clause. So now I'm going to move on to my findings, which is that again, like we have a lot of clustering near the end. And if you look closely, which I imagine was very difficult for you, but I'll post the slides on the Discord. Attention head 3 of layer 11 contributes to all three circuits. So maybe now disambiguation does actually have some centralization despite my prediction, which would be super surprising to me if I could find something that, fires for all of that. See, I only made 3 data sets, but I could make more than, I just want to talk about one biggest limitation that I have. So see, context will alter the probability distributions outputted by the model, right? The predictions that it has for what token will be next. But the priors are based on the training data, right? If in the training data, one word is more frequent than the other, it will require, okay, sorry, I ran out of time, but I'm just going to continue, right? See, yeah, see, the other people, they were wishing for me to take a long time so they would have less time to present, right? So I'm going to fulfill their wish by taking my sweet time. If a certain sense of the word is more frequent than another in the data set, it will require stronger context to push the model to accept the other one. Because, it's like Bayesian updating, right? So you have to have stronger evidence in order to be able to counteract it. So I picked prompts that were easily steerable. See, I went through like a long, long list of words where you would get results like this. On the boat, I saw a seal in the sea. Was the seal an object or an animal? It was an animal. Okay, makes sense. And then see, in the market, I saw a seal on the box. Was the seal an animal or an object? It was an animal, right? So it's like, this makes no sense. But it must be, I think this is the case because seal as an animal is so much more common in the training data set of GPT2-small, which is, oh, it's not going up. I want to go back. I'm pressing up. Yeah, so the training data for GPT2-small was web text. So really what I ought to do is see which senses are more common and calibrate on this, but that would require like examining so many things and like didn't have time for that. It would be really good to do though. Perhaps there will be some way to automate it. So some pieces of future work that would be good is it would be good to try more nouns, more data sets, more good. You love data. And it's not, sorry, it's just, okay. Yeah. It will also be interesting if doing multiple changes in the prompt yields the same whole model changes like in the bow case, right? So if I did another data set that was like that, would it also exhibit that thing? Because I do know that, there are like, for example, in, you have stuff like IOI, right? Where it requires like multiple different token positions have to be considered. And also, attention head layer 11, head 3, very interesting. I want to try ablating it and then asking the model to continuously generate and see what comes out. That seems like it will be an interesting thing to try. So now question is answers.
Yeah, we have a question from our in-person audience.
Comment front and for the benefit of our Zoom audience.
Okay. So hello. First of all, I would like to congratulate you on your successful presentation. It was really understandable, and I enjoyed listening to it. So anyway, one of the homographs you studied was bow, right? If I'm not mistaken. There are actually 3 meanings I could think of. Yeah, bow as in for a bow and arrow, that was bow, and the violin bow. So mhm. Um, do you have any plans to test the homographs with more than two meanings, or do you think the results will be the same? That attention head 3 for layer in layer 11 will contribute the most to it.
Yeah. I think that would be interesting, although I would have to rework my methodology, perhaps doing something like, pairwise combinations, because as of now, the way the methodology that I'm doing, it requires some like pairs of pronouns and then they're compared, right? So if I have more than two, then I would have to do something like maybe it's like you do like a triangle or something like that. Yeah. So that does seem to be very interesting, and especially if like it's very like different between the word senses. Yeah. Thank you so much for your question.
So, anyone else? Questions?
Yes, anyone else have questions? Even our Zoom audience, you can just speak it out loud since we don't have Slido questions yet.
Yes, you can just go on chat.
Or really unmute yourself. The audience will hear you.
Oh, I think you have to talk to your that mic.
Oh yeah.
So,
We have a in-person question again.
Do you think it makes a difference that the three examples you put were all started with the letter B? So it was bat, board, and bow, which is, they're like, I'm thinking like, what if, because they're close, like they're kind of spelled similar, they all start with the letter B, then that's the reason why they're clustered together in some cases.
Thanks. So on priors, I would think that that's very unlikely that them starting with the same letter had a significant impact because, right, the model thinks in terms of tokens, not letters. So when it sees the word like say bat, it doesn't consider it like BAT, then these combine to form bat. It just receives bat immediately. So it doesn't really think of it as like having those letters unless you explicitly prompt it to spell. And indeed, like, there are like these threads on Twitter that you can see like people asking ChatGPT to spell and it can't spell because the tokenization makes it hard. If you ask it to spell, then you'd have to break up the word into its individual tokens. So that's like difficult for it. It's not like trained specifically for that. Thank you for your question.
thanks. Yeah, so anyone else? So, floor is open for questions. So, Zmavli here is our, I don't know, resident linguistics person. It's a lot about languages. Maybe on Zoom, sorry.
Yeah.
Sorry,
Oh, there's one question on Slido. So how would you consider evolving language such as cap that could mean a headwear or cap as in the slang no cap?
Well, for that, right? So for GPT specifically, it's a generative pre-trained transformer. So once it's been trained, it can't learn anymore. So if the slang came after the corpora it was trained on, it was set, then it wouldn't have any knowledge of it, right? It wouldn't have any knowledge of it except insofar as you can fit it into the context window of the model. So I guess for evolving language, like, maybe we could like consider models that could like learn continuously, although I don't have any experience with that. All of my work has been with pre-trained transformers. Sorry about that.
All right. So yeah. So we have two more. Yeah. So we have two more questions. So, are there particular limitations in GPT-2-small's ability to disambiguate homographs compared to larger models like GPT-3 or GPT-4?
Right. I don't think there are particular limitations it has that aren't shared by the other ones because they have fundamentally the same architecture, right? Like attention, then MLP, then attention, MLP, so on and so forth. It's just that like the other ones are just much bigger, right? And you know, like size is a property all on its own. So I don't think there's something specifically that I could point to aside from GPT2-small is small. So it has trouble with like the rarer homographs or the homograph meanings. Yeah. So I think that might be a unsatisfying answer for you. Should I answer the next question?
Yeah.
All right. If bow means weapon, action, musical instrument, and ribbon, would we know if C and D were also evaluated by the model? So sadly, my prompts don't account for that, except insofar as like they ask you if it's an object or it's an action. So there, the musical instrument and the ribbon would just be folded into the object. Although with the context that I provided, they were steering specifically into the weapon. They're not leaning towards like the ribbon and the musical instrument interpretations. So yeah, that was apologies for that. That wasn't something that I explicitly studied. Oh, I don't know how. All right.
Yeah, I think that's all for our
Yeah.
Q&A. So
Sorry,
thanks
just one-
again, Zmavli, for your presentation.
Yeah. Thank you so much. Now, oh my goodness. You really ruined the moment for me. See, now I will make a bow. Thank you so much, everyone.